Hi students, this is Mr. Plum, your math teacher, coming to you actually on Thursday from last week. Again, I will not be here today or tomorrow, so Monday or Tuesday. However, you do have math today and tomorrow. We're going to be doing some review of the multiplication strategies today, and then tomorrow's lesson is going to be on word problems, multi-step multiplication word problems. We're going to do a review of that. So what I need you to do right now is get out a whiteboard and a marker or a notebook and a pencil. And the plan for today, I'm going to give you, I think there are 6 different multiplication problems. I'll share my screen. And what I want is for you to choose the strategy that you would like to use. You can do partial products, area model, lattice. I would even allow traditional if you know it. So again, today the goal is going to be for you to solve these multiplication problems accurately. The only strategy I do not want you using is a calculator. Okay, calculators are not going to be allowed today or tomorrow or on Wednesday. If you ever want to check your work after doing some partial products or area model or lattice or traditional and want to check your work to make sure it's correct, you could use a calculator, but never on the initial aspect of trying to understand the basic facts. Always try to work those out. Okay, so we're going to start with 517 times 8. That's your first problem. So what I'm going to do is I'm going to present the problem, and then I'm going to pause. And that's what you should do as well. So you'll see it, you'll write it down, and you'll start working on it, and then you'll hit play, and then I'm going to explain it. Okay, so I'll show the problem, you hit pause, write it down, do all of your work, and then you hit play, and I'll go through the 3 different ways you could do it, so you'd be able to understand what you got right and what you got wrong. Okay, so we'll start with this first one, 517 times 8. Go ahead and hit pause. And then when you're ready, hit play, and I'll explain how to do this problem. So if you're doing an area model, you would create your box, and you'd have 500 plus 10 plus 7, because you will have broken 517 into 510 and 7. And then solving the problem, 8 times 5 is 40, with the 2 zeros is 4,000. 8 times 1 is 8, with the 1 0 here is 80, and 8 times 7 is 56. If you were to do partial products, you would have 500, 10, and 7, and you'd multiply all of those by 8. Again, getting 40 plus the 2 zeros, 80 and 56. And if you were doing lattice, you would have your box set up. You would have 5, 1, and 7 at the top, 8 on the side, and then again, corner to corner and through, corner to corner and through, corner to corner and through. When you're creating your lattice boxes, just make sure that you're cutting them in half from the top corner to the bottom corner. As you can see, mine are not as beautiful as the work that we did in class when they were already created for us. Just do your best, okay? 7 times 8 is 56. 1 times 8 is 8. And 5 times 8 is 40. Now, as we're adding all of these together, so the initial problem, that would be your addition. Again, your addition. You'd have 6, 13, whoops, I put the 1 in the wrong spot. This would be a 1 and 4. Same thing down here. And then you're adding diagonally. So we have 6 in this first diagonal. Second diagonal would be 8 plus 5 is 13. So we'd put a 1 in the next diagonal, which is our next place value. So that would be a 1 now instead of zeros, and then 4. So regardless of how you solve the problem, your answer is 4,136. Okay. So if you want to pause now to look over your work, check to see why you got what you got wrong, whether it was, okay, yep, I didn't multiply, or I multiplied incorrectly, or I didn't line up my numbers right. No, I didn't add along the diagonal. Try to identify why you got it wrong, if you got it wrong. Next problem is 495 times 6. So again, hit pause, and then you'll be able to follow along as I go through it. 495 times 6. All right, so area model. 495 multiplied by 6. 6 times 4 is 24 with the 2 zeros. 6 times 9 is 54 with 1. And 6 times 5 is 30. If I were doing partial products, I would set it up as 495, and I'm going to multiply all of those by the number 6. So again, get 2,400, 540, and 30. Now, I know many students, when it comes to this 90 times 6, you might not know that one. Remember, you can always set up 6 nines on the side and add those together, or 9 6s. And then add those together to get your 54. And then last, your lattice box. 4, 9, 5, and 6. Okay, so this would be 30, 54, 24, and then you're adding along your diagonal. So the first is 0, 7, 9, 2. If you had this one written out, same and same. So 2,970, regardless of how you go about solving that problem. Okay, so check your work. Hopefully you got that one right. We'll move on to the next one. Now we're doing 2-digit by 2-digit. This is 62 times 89. So go ahead and pause the video, and then you'll be able to come back. It is 62 times 89. All right. Hopefully that went well. Area model, you got a larger square looking shape this time. I'll put my 60 and 2 on that side, 80 and 9 up here. If you have those reversed, that's fine. You'll still get the same answers or same numbers to add at the end. 6 times 8 is 48 with the 2 zeros. Maybe we'll do black in this next spot. 6 times 9 is the same we did for the last problem, so that'd be 540. 160 for this one, and 18. If you're doing partial products, you could set it up a couple of different ways. So maybe you do the 60 and the 2, you decompose those first, and then multiply this by 80, and this by 9, by 80, and by 9. The idea with it set up this way is we have our largest product going all the way down to our smallest product. Okay, so 6 times 8 is 48 with the 2 zeros. 6 times 9 is 54. 54 with the 1. 2 times 8 is 16 with the 1. And 2 times 9 is 18. If we're doing lattice, another big square. Okay, so we have 6 and 2, 8 and 9. So 16 here, 48 there, 18, and then 54. 8, 11, that's 13, 14, 15, and 5. If we were to add these together, we would have 8, 11 again. 6 plus 8 is 14, plus 1 is 15. Another 5. And then the same thing if we added those together. Okay, I'm going to go tell some students they need to quiet down a bit outside. So I'll have you start this problem. The next one is 75 times 94 whilst I go and tell them to quiet down. Okay, so hopefully I can hear myself thinking now. You should have paused already at this point to start this problem, 75 times 94. If not, hit pause now, and then I'll start. Okay, 75 times 94. If we're doing area model, 70 and 5, 90 and 4. Ooh, these boxes are small. 6,300, 450, 280, and 20. Those are the 4 totals that should be in your boxes. Maybe you want to set this one up as 90 and 90 and 4 and 4, and then multiply by 75, 70, and 5. As long as you're separating one of the sides, notice how these are being separated instead of doing the same number in a row. As long as you're separating one of the sides, you should be fine. With your partial products, 6,300, 450, 4 times 7 is 28 with a 0, 4 times 5 is 20. Adding those together is what I'll do when I'm done with this beautiful lattice box. 7, 5, 9, 4. Again, corner to corner and through, corner to corner and through, corner to corner and through. So this would be 45, 20, 63, 28. Adding along the diagonal, so this would be 0, 8 plus 2 is 10, plus 5 is 15. I'll just sneak my 1 in there. So 4 plus 3 is 7, plus 1 is 8, plus 2 is 10. Again, I bring up a 1, and that would be 7. So 7,050. See if I get the same answer for these. 5 plus 8 is 13, plus 2 is 15. 1 plus 3 is 4, plus 4 is 8, plus 2 is 10. 1 plus 7 is, 1 plus 6 is 7. So whether we add these numbers or do partial products to get the same answers, 7,050. All right, I hope you're holding up. We've got 2 more problems. This time we're getting into 3-digit by 2-digit. I believe in you. You got this. I know this is a lot of work, but you can do it, and this is good practice because next week on Wednesday you're going to be, on Wednesday of this week, you're going to be testing, and you'll get problems just like this, and you'll be expected to be able to do it. I'll give you a moment to pause, write this problem down, and then I'll get started on it. Okay, I'm gonna just try to give myself some room. Got a big problem coming. So 791 versus 81. All right, 8 times 7 is 56 with 3 zeros. 8 times 9 is 72 with 2. 80 times 1 is 80. 700 times 1 is 700, and 90 and 1. So those should be the answers for your 6 boxes. Partial products. Again, really big problem here. So we would have, I'm going to decompose 791 into 70, 90, and 1. I'm going to do it one more time because I'm multiplying by 2 digits. I'm going to multiply it by 80 the first time and by 1 the second. I think that works out. Yeah. Okay. So this would be 56,000 and 7,200 and then 80. This would be 790 and 1. And I would add all those together. If I'm doing a lattice box, another huge box, 79181. Break it down by the place value. Corner to corner and through, corner to corner and through, corner to corner and through. 1 times 8 is 8. 1 times 1 is 1. And we have 72 and not 9. And then we have 7 and 56. Adding with our diagonal. So here's 1. Second diagonal, we have 8 plus 0. 8 plus 0 plus 9, which is 17. Third diagonal, we have 7 plus 1 is 8 plus 2 is 10. 1 plus 7 is 8 plus 6 is 14. Last diagonal, 1 plus 5 is 6. So our answer is 64,071. If I add all these, I get 1. 8 and 9 is 17. 1 and 2 is 3 plus 7 is 10. That would be 14 and 6 for the exact same answer. It's taking a lot. If this strategy right here, having all those numbers is too much for you when you're lining it up for area model or even partial products, I would recommend trying to add perhaps the columns first. So this would be 56,700, and this would be 7,290, this one right here, and then this would be 81. So it's a little bit less to look at and worry about. So that was the first one. And let's look at the last problem of the day. 505 times 78. The last one of the day, 505 times 78. Go ahead and hit pause and come back when you are finished. All right, so area model. I'm going to make this one more of a square. You could do it a couple of different ways, and I'll show you both. So first way, knowing that this tens place right here means nothing, it's 0, it's not going to give you any value, there's nothing that's going to come of that you would add, you just get rid of it right in here. So you have a 500 and you have a 5, and you do your multiplication. The other way you could set it up, you could put it in there like that. And then just know that 70 times 0 is 0, so you're not going to have any value. Either way, you're going to have the same numbers. 35,350, 4,040. Those would be the same numbers that you'd have over here. It should be 3. 40,000 or 4,000, and this would be 40. Mr. Leaser is trying to get a hold of me, so I'm just going to pause. Okay, I am back, and we did the area model there. I'm going to erase this to give myself some room for the other two. 505 times 78. I would do the same thing for partial products. 500 and then 5, 500 and 5, and multiply that by 70 and by 8. Um, 7 times 5 is 35 with 3 zeros. 5 times 7 is 35 with just 1. And then 5 times 8 is 40 with 2 zeros, would be 4,000. And that would just be 40. Now we're doing lattice, however, there's no way around it. You would have all of the digits. 7 and 8. Corner, corner through, corner, 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 corner through. That one isn't beautiful, but I'll make it work. So my first set, 5 times 7 is 35. 5 times 8 is 40. These are all zeros because we're multiplying 7 times 0, 8 times 0. And then again, I have a 35 and a 40. Counting, let me do green. Adding my diagonals, this would be 0. This would be 9. This diagonal is just 3 plus a bunch of zeros is 3. Again, 4 plus 5 is 9. And then 3. So we have 39,390. Let's see if I'm right. I'll add up my partial products here. Zeros give me 0. 5 plus 4 is 9. 0 plus 3 plus 0 is 3. 4 and 5 is 9 again. And then I just have 3. So yeah, 39,390. So that was 6 multiplication problems, no context, no word problems or anything like that, just multiplication. You will have 2 of those on your quiz on Wednesday. 2, where you'll need to be able to multiply multiple digit numbers, 3 by 2s. So if you need to practice tomorrow or in the next hour or so, keep going. IXL has skills that are 3-digit by 2-digit, or mom or dad or brother or sister, grandpa, grandma, aunt, uncle, whoever could create problems for you. You could create them yourself, putting 3 digits by 2 digits. If you are really struggling, you can go ahead and email me, and that will help me to know heading into Wednesday that you're struggling with this multiplication. But my hope is that by giving you those 3 strategies, that you can find one that you love and that makes sense and it works every time or almost every time. You got to kind of figure it out. So that is the end of today's lesson. I'm going to now start tomorrow's lesson. So I will see you in a moment. Share and